gun that shoots flawlessly is something Beretta USA takes great pride in. If a misfiring or jamming gun were to make it to the marketplace, it would be a devastating blow to the company's nearly 500-year history as a high-quality gun manufacturer. Not to mention a possible life or death situation for the men and women carrying them. When developing new pistols, they use high-speed cameras to analyze every detail of how they fire.
I'm David McCallum, and this is Beretta USA.
At their only U.S. plant located in Accokeek, Maryland, David is the Vice President of Manufacturing and Engineering. Here, they manufacture 4 different types of pistols.
Here at Beretta USA, we make the Bobcat Tomcat family of small pistols, the PX4 subcompact, the Neos target pistol, and the M9 pistol for the military.
In 2009, they estimate they'll make about 116,000 guns, many of which will be used by the police and U.S. Armed Forces. All of them are machined, hand-assembled, and tested here on the premises.
We focus on manufacturing 3 major components for the pistols. The frame, which is this part here, comes in as an aluminum forging, and we machine it.
This forging goes through several phases of machining.
And it comes out as a finished frame, which we 100% inspect to ensure quality and it functions in the field.
After painting and heat treating, all the other major components meet up in the assembly room.
So everything comes to this room and we assemble the pistols by hand.
Then they head to testing.
These are guns that are ready for testing, so this is where we do the 1 magazine commercial and 2 magazines for military, and they're tested in that back room right there.
But before any gun even makes it to this point, they go through several phases of development.
In the process of designing a new gun, it's basically 3 steps that we start with. We construct a model, a 3D model with our CAD system based on the specifications that we've worked up from an engineering standpoint. At that point, we do an SLA, which is basically a plastic model of the gun, more so to determine if it feels right in the hand and it looks like we think it's going to look like coming out of the 3D model. At that point, we'll go into hard prototyping, where we'll make actual prototypes that we can fire. And it's at that stage that we'll use the high-speed camera to verify 2 main issues. The main thing we want is the gun always to function as it's supposed to, because we view that as a safety item, whether it's a commercial user or certainly in the case of the military user or the law enforcement user, we never want the gun to jam. And there's 2 ways it can basically jam.
Issue number 1 is making sure the gun pulls the spent shell out of the barrel, then ejecting it out of the gun correctly.
And the other piece we're looking at is to make sure that as the bullets, which are in the magazine, feeding up this way, that they feed back into the barrel correctly and that there's no chance of the bullet jamming when it goes into the barrel, or a chance of the bullet jamming with the bullet that's following it beneath in the magazine.
A bullet leaving a Beretta 9mm pistol is traveling at speeds of 1,000 feet per second. The spent shell isn't traveling that fast, but flies out of the gun at a fast rate. So fast that it's hard to get a visual of how it's reacting when the gun's fired.
So what we'll do is do the high-speed camera work there and make sure that, and we'll see that when we film it later, that it's ejecting properly, that the timing that we've calculated in our engineering calculations are correct, and we don't have to change any of the linkages in the gun.
Using a high-speed camera is the only way to see the details. Beretta's resident gun tester is Arthur Peckson. He set up a demonstration of a standard gun test and fills us in on what he's hoping to capture with the high-speed camera.
When the empty case is extracted from the chamber and hits the ejector, and you can see the empty case fly out, it's important that the case ejects consistently. We've noticed on some guns that you can have erratic ejection.
He's ready for the first test using the Beretta PX4 Storm 9mm pistol.
Ready. 1, 2, 3.
In real time, it's difficult to analyze any details of the ejecting shell, but in slow motion, new details are revealed. When the bullet is fired, the spent shell ejects in a fraction of a second. If a jam were to occur, it would happen at this precise moment, as the gun ejects the spent shell and reloads. Then the recoil forces the gun back. Arthur sees no erratic ejection this time. But he sets up for another test. This time he'll fire consecutive shots. The purpose is to make sure the spent shells are ejecting with the same trajectory. Spent shells ejecting in different directions is an indication that an engineering calculation may need to be corrected, sending a gun back to the drawing board. Arthur fires 3 times. All 3 shells have identical trajectories, indications of a perfectly engineered pistol. After the prototype passes initial testing, they'll manufacture about 1,000 pre-series guns.
From that group, we'll pull 100 of those and go through all the test firing and also do reliability and durability testing on the system. And it's important to do it in both cases, the first one to make sure the design is correct, and the second one to make sure that the manufacturing process that we've set up and that we're going to deliver into the field is working correctly.
These are just a few of the tests Beretta puts their guns through, but the only ones that can't be seen with the naked eye.